Okay, in this module, we're focusing more on looking at insoluble salts rather than soluble salts. We saw soluble in the last module with what is the pH of. All our salts were soluble there. What we're seeing in this new module is what happens when we run into an insoluble salt. And we can ask, what is the pH of an insoluble salt? So that this little piece goes with our flow chart. But first, we have to learn how to handle the insoluble salt. Now, it works very similarly to the soluble salt in that it does break up into ions, but it is not 100%. So there is an equilibrium reaction. There's going to be an ice table. And there's going to be an equilibrium constant for that equilibrium reaction, and we call that a KSP. For solubility product. So there are several kinds of questions we run into. This is not to replace your lecture videos, but for example, let's say we have the question, if the solubility, so it's telling you how soluble the salt is of copper 1 bromide, which is CuBr, is just totally making up this number, 4.2 times 10 to the minus 8 molarity at a certain temperature. What is the KSP? All right. So it telling you the solubility of that insoluble salt tells you how much dissolves. Let me just point out in this module, you're going to see a lot of names instead of formulas. This is the time to go back and review your nomenclature, your ionic nomenclature from Gen Chem 1. You can do some Googling, but you want to confirm it. Make sure that it makes sense. Post on the discussion board if you've got questions about names and formulas. You've got a lot of support with the materials in this module, but you are going to have to come up with some of these formulas on your own. So at a certain temperature, what's the KSP? We can't go to the tables to look up the KSP for this. We do have some tables because it's of this word, at a certain temperature. The tables of KSP values are for 25 degrees Celsius. That is the standard thermodynamic temperature. But as we learned in the module about equilibrium reactions, our first one, if you change the temperature, the equilibrium constant changes, therefore it's not necessarily the value from the table. So we need the equilibrium constant for copper 1 bromide. The pattern on these equilibrium reactions that we see up here is exactly the same every single time, just like with the weak acid, here's the pattern, with a weak base, here's the pattern. With the salt, first break it up into ions and then figure out what it is. With an insoluble salt, the pattern for the equilibrium reaction is exactly the same. It is the solid salt in equilibrium with the ions that make it up. You have to pay attention to stoichiometry. This is where your nomenclature comes in. And so for copper 1 bromide, that will break apart into the copper +1 ion and the Br- ion. And you should be able to write that from either the name or the formula. I'm going to have an equilibrium reaction, which means there's an equilibrium table. It's looking, this particular question is looking for the KSP. So that means it must be giving me enough information about the equilibrium amounts to plug into the formula for KSP. And the formula here for KSP is products over reactants raised to the stoichiometric coefficients. So it's Cu plus and Br minus, both of them raised to the first power, but I do not put that over the solids. Oops, I don't want to say that's X. I do not have to put those over the reactants because this guy is a solid and solids don't show up. So my equilibrium expression is just that, where the Cu plus and the Br minus are the equilibrium concentrations of those guys. And so what are the equilibrium concentrations? Well, the solubility is 4.2 times 10 to the minus 8. That tells you when I start with a certain mass of that initially, the change, the amount that dissolves is 4.2 times 10 to the minus 8, which means that my ions, since they're 1 to 1, will both increase by 4.2 times 10 to the minus 8. So KSP is very simply 4.2 times 10 to the minus 8 for copper, 4.2 times 10 to the minus 8 for Br minus, the copper ion and Br minus. I can just abbreviate that. I can write that more succinctly. And 4.2 times 10 to the minus 8 squared. I'm going to go to 2 sig figs, 1.8 times 10 to the minus 15. It's unitless, just like all of our other Ks. So I can quickly calculate the KSP by plugging into the formula using the solubility, thinking of the ice table or drawing an ice table and plugging into the formula. If the stoichiometry is not 1-to-1, it gets a little more complicated, but it's not bad. Let me just randomly pick a formula. Let's see. An ionic compound, lead 2 phosphate. All right, at a certain temperature, because I'm making up numbers. Lead, Roman numeral 2, phosphate has the solubility of 3.6 times 10 to the minus 12 molarity. All right, I'm sure at some temperature it does. Again, I'm just kind of making these up. What is the KSP? All right. In order to calculate the KSP, I'm going to use that solubility to determine what the concentrations of the ions are at equilibrium so I can plug into it. The first thing I've got to do is write that equilibrium reaction. And you may notice the first thing I have to do is figure out the formula. I teach in my Gen Chem 1, when you are figuring out the formula, you should have a strategy. And my first strategy is, since that's an ionic compound, it's made up of ions. What ions? It's made up of the lead 2 ion and the phosphate ion. That's where it gets its name. So what is the lead 2 ion? You should recognize that that Roman numeral means that that's the lead plus 2 ion. What is the phosphate ion? You may need to look this up. You may need to have a table of polyatomic ions handy so that you don't have to memorize them, or you can memorize them. The phosphate ion is PO4 with a -3. And so the formula for lead 2 phosphate is PB3 PO4 2. That's all Gen Chem 1 coming up with that formula. Review it if needed. The equilibrium reaction then is this guy breaking apart into the ions. And since I did this scratch work, I now know what goes in the products. The Pb plus 2 ion goes there, and the PO4 minus 3 ion goes there. And I do have to balance it. And so I'm going to have 3 of these and 2 of these. There is some stoichiometry involved in these problems. I know we had our 1-to-1 stoichiometry for acids and bases. Well, that's gone now. All right, so what is the KSP? The formula is the concentration of Pb2 plus to the 3rd power, the concentration of PO4 minus 3 to the 2nd power. So that's the formula, that's the equation that I'll use to solve for KSP. But how do I get those equilibrium values? Well, the solubility is this. That tells me that when I start with some solid lead 2 phosphate, 3.6 times 10 to the minus 12 molarity breaks apart, dissolves. And so how much lead ion would dissolve? 3 times that amount. How much phosphate ion would dissolve? 2 times that amount. You see where I'm getting the 3 and the 2? It's the stoichiometry. So when I come down here to plug it into and solve for my KSP, I have 3 times 3.6 times 10 to the minus 12. That's all cubed. The cube comes from the equation for KSP. The 3 times comes from the stoichiometry. It comes from the same place, but it serves 2 different purposes. And then 2 times 3.6 times 10 to the minus 12, and that's all squared. And so let me punch this in. You guys double check my math and please post if you find a mistake. That is to the third. This is a good time to make sure that you know where to find raised to the third on your calculator. Times 2 times 3.6 times 10 to the minus 12th, all squared. I am getting let's go to 2 sig figs, 6.5 times 10 to the minus 56. Let me double check. Times 6.6. Yep. And so that's the KSP at that particular temperature.